Hi. So in this example, we are going to determine the distance of this segment here. Okay, so what we do know is points A and B are separated by a lake, so this is like a lake. And to find the distance between them, a surveyor locates a point C on land such that CAB is 53.2 degrees. Find the distance across the lake from A to B. Okay, so there's a couple of things that we may need to understand. The first thing is when they give you two sides and one angle, and we can see that it's not going to be a perfect right angle, that we'll go ahead and have to use the law of sines. So the law of sines says that you're going to have the sine of the angle divided by the side, which is equal to the sine of the next angle B in the opposite side, which is equal to the sine of the other angle over its opposite side. So essentially what we're saying is the angles of a triangle are proportional to the opposite sides. And so we could use proportions to be able to solve for one of the other missing factors. Okay, so the second part here is notice they give you the opposite side of B and the opposite side of A. But in order to find this angle, this edge here from A to B, I would need to know this angle opposite from it, right? So we can always call that angle C, and this would be the edge, little c, in our formula of the law of sines. So let's go ahead and do that. So the first thing we're going to have to do is find the angle in order to find the missing side, right? Because we can't have two things missing and solve. We always only need one thing missing. So we're going to have to probably find this angle before I can find this side, and that way I can use maybe angle A in this opposite side and then this angle and to find the opposite side. I have to know one or the other. We don't need to know all three of these things. We could just know these two and be able to solve a proportion, or these two and be able to solve a proportion, or these two, and you kind of get the idea. So let's go ahead and write down the steps. So the first thing we want to do is find angle C by finding angle B. And then we can find the length AB. Okay, because then we'll know angle C, and then we can use the law of sines. So now that we have those, let's go ahead over here and start. So the first thing we'll want to do over here is set up a proportion and find angle B, or the measurement of angle B. Okay, so the sine of the angle given, 53.2, all over the opposite side here, 53.7, equal to the other side with angle B. So we're going to put sine of B over its opposite side, which is 320 feet. Okay, and then solving this out, we can get 320 sine of 53.2 degrees divided by 537 is equal to sine B. And then, of course, we can find B by taking the inverse sine of this whole quotient, 320 sine of this angle, 53.2 degrees, over 537. Okay, and when you do this, what you'll need is to put your calculator in degrees. So let's put a note here, put calculator in degree mode. Okay, so you can go to your calculator. I'm using Desmo, so I have to make sure it's in degree mode. I hit this little wrench up here in the top right corner, and the wrench here should have in radians or degrees down below. So I'm just going to go ahead and select degrees. Great, and then I'm just going to double check and it's in degrees. Now I can go ahead and input that expression. So recall that it was going to be the inverse sine of 320 of 320 sine of 53.2 parenthesis divided by 537. Okay, and notice that gives us 28.4999, so about 28.5. So B is equal to 28.5 degrees. Awesome. So here I'll put 28.5 degrees. So now what is angle C? So the next part, part 2, would be to calculate angle C. And so the measurement of angle C is equal to, well, 180 degrees, because that's the total number of degrees in a triangle, minus the 53.2, and then minus the 28.5. So we can go ahead and just do that in our calculator. Do 180 minus 53.2 minus 28.5. And so we get 98.3. Excellent. So now we have 98.3. And if we add all three of these up, it should be 180. Now I have angle C with the opposite side that we don't know the length, and that was our goal. And we can use angle A and the opposite side, or we could use what we found in angle B and the opposite side. It's really up to us. But now we're ready. We finally can go ahead and find the distance from A to B. Okay, and that's simply just doing the same thing. So we're going to have sine of 53.2 divided by 537, and that is equal to sine of 98.3 over the side here, which is AB, but we called it C just so it matched with our formula. So this means that C will be equal to, solving the proportion, 537 times sine of 98.3 divided by sine of 53.2. So when you do this, once again, make sure that you are in degree mode, right, like here. And so let's go ahead and put that in the calculator. So here we have 537 sine of 98.3 divided by the sine of 53.2. And so we can see that is 663.61. Great, and so now we know that the distance between A and B is 663.61 feet.